Hello, I'm Rasel Mahmud. I'm a PhD student from University of Texas at San Antonio. I'm very happy to share our research work, auditory feedback for standing balance improvement in virtual reality. Virtual reality techniques are becoming more popular day by day in many sectors like rehabilitation, education, physical fitness, and entertainment. However, one of the major issues with VR is that it causes imbalance for users, which is severe for people with disabilities, because people with disabilities usually have some balance issues, and added imbalance by VR makes it difficult for them to benefit from consumer VR applications. To solve this issue, our research investigated the effect of different auditory feedback on balance in VR. The purpose of this research is to make immersive VR more accessible using auditory feedback. There are several motivations behind this work. Many prior research work has reported the imbalance effect caused by VR, but minimal research has been conducted to reduce this effect. Also, most of the previous research only included the participant without disabilities, which motivated us to investigate both people with and without disabilities. Most rehabilitative approaches to improve balance have not used head-mounted displays or usually constrained to seated tasks. So we used head-mounted displays and evaluated standing tasks in our study. Spatial, center of pressure, rhythmic, static rest frame audio improved balance in the non-VR environment, which motivated us to investigate this auditory feedback in VR. We recruited 42 participants from the San Antonio area. 21 participants had balance impairments and 21 participants are without balance impairments. We had one baseline without VR condition that we performed at the very beginning of the study. We also had 5 VR conditions. For spatial audio, we specialized white noise from Unity 3D using Google Resonance Audio SDK. Static rest frame audio was white noise played in headphones. It had no relation to the listener's position. For rhythmic audio, we played white noise beat at every 1 second interval. For COP audio, we played same white noise beat as static rest frame audio in headphones, but the pitch and stereo pan changed based on the center of pressure path obtained from the balance board. For no audio, participants still ordered the headphones to make it consistent with other conditions, but no audio was played. This was the standing visual exploration task. We placed different markers, left, right, top, bottom, front, in respective directions in the lab. We wanted all the participants to observe the lab in a controlled fashion. We collected real-time balance data from Bittrex balance plate. This was the standing reach and grab stacks. Participants reached for and grasped real and virtual objects within their reach. We instructed participants to grasp the 4 objects in random order, lift the objects to chest level, and put them back in the same place. The flowchart shows the whole study procedure. At the very beginning, participants filled out a COVID-19 screening form, a handedness questionnaire, ABC questionnaire, and a pre-session SSQ form. For baseline tasks before VR, Participants stood on a Bittrex balance plate while they are supported by a harness to protect them from falling. Then we measured their balance data for the standing visual exploration tasks and for standing reach and grab tasks with 3 trials each. VR tasks are the all replication of the above baseline tasks except they are performed in VR. We repeated the standing visual exploration tasks and standing reach and grab tasks for 5 different auditory conditions and 3 trials for each session. The auditory conditions and the tasks are counterbalanced. Finally, participants filled out a SSQ form and a demographic questionnaire. Participants received $30 per hour and a parking fee at the end of the study. IRB at University of Texas at San Antonio approved the study. We had 3 metrics. Center of pressure velocity was the primary metric for our study. We calculated center of pressure velocity from the balance board data to measure participants' balance. ABC questionnaire is a 16-item questionnaire that asks about participants' confidence in doing a specific daily life activity. SSQ is also a 16-item questionnaire where each item asks participants' physiological discomfort. For statistical analysis, Shapiro will test revealed that data are normal. Next, we used 2x6 mixed model ANOVA, where we had 2 Bedouin subject factors, which is participants with balance impairments and participants without balance impairments. We also had 6 within subject factors, the 6 study conditions. Finally, we used post hoc two-tailed t-test to find specific difference between any 2 study conditions. We also used post hoc two-tailed t-test to measure cyber sickness and to measure difference in physical ability between 2 participants groups. This was the result for standing visual exploration tasks. The left figure shows that COP velocity increases in no audio in VR conditions, whereas COP velocity decreases in all other auditory conditions in VR. As balance increases with the decrease of COP velocity, we can see spatial and COP auditory feedback improve balance significantly than other conditions. We found similar result for participants without balance impairments, where spatial and COP auditory feedback outperformed others. We also found similar result for standing reach and grab tasks, where spatial and COP auditory feedback outperformed other conditions for both participants with balance impairments and participants without balance impairments. The result demonstrated that spatial and COP auditory feedback improved balance significantly more than other auditory conditions. Spatial and COP auditory feedback changed based on the participant's positioning. So we hypothesized that the audio volume that changes with participants' positioning provides significantly better feedback to the participants to correct their posture. There was no significant difference of the virtual environment on balance. Also, we didn't find any significant increase in cyber sickness after two-tailed t-test. In our study, all auditory conditions improved balance, where spatial and COP auditory feedback outperformed others. However, spatial audio may be preferred over COP audio, as spatial audio provides greater immersion in VR. This work will help researchers and developers to create more usable and accessible VR experiences for both people with and without balance impairments. Our future work includes locomotion tasks and investigating the effect of auditory feedback on gait in VR. Here are the references. I would like to thank NSF for funding this project. Thank you.